Hello and welcome everyone. It's our pleasure to have you here with us today. We are here to assist you, so let's embark on this journey of knowledge and conversation together. Later, you'll get to meet my other companions to explain more knowledge about logic gates, but first, let me explain to you what logic gates are. These are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. So in a circuit, logic gates will make decisions based on a combination of digital signals coming from its inputs. So most logic gates have two inputs and one output. Logic gates are based on Boolean algebra, where at a given moment, every terminal is in one of the two binary conditions, which are false or true. False represents 0 and true represents 1. So we have here the different basic logic gates. So first, we have the OR gate. So as you can see on the picture or in the diagram, OR gate has its own curve on its two basic edge of its symbol. So the OR gate outputs a 1 if either or both of its input are 1. Otherwise, it outputs a 0. So as you can see on the table, you'll get to see the input and out of the two input and one output of OR gate. So the next gate, we have the AND gate. So same input, which is the A and B. So AND gate outputs a 1 only if both of its inputs are 1. Otherwise, it outputs a 0. So based on its diagram, it has a straight line on its edges of its symbol. So the next gate, we have the NOT gate. So NOT gate, also known as inverter. So as you can see on its symbol, it is basically an arrow, uh, which shape triangle, and it has a small circle on the upper head of its shape. So a NOT gate inverts its input. If the output is 1, the output is 0. If the input is 0, the output is 1. So that is our NOT gate.
So, hello everyone. My name is Jacob Ong, and I will discuss about the other logic gates. NAND gate. The NAND gate is a combination of the and NOT gates. It outputs a 0 only if both of its inputs are 1. Otherwise, it outputs a 1. NOR gate. The NOR gate is a combination of the OR and NOT gates. It outputs a 1 only if both of its inputs are 0. Otherwise, it outputs a 0. XOR gate. The XOR gate outputs a 1 if one or the other of its inputs are 1, but not both. Otherwise, it outputs a 0. XNOR gate. The XNOR gate is a combination of the XOR and NOT gates. It outputs a 1 only if both of its inputs are the same. Otherwise, it outputs a 0.
Hey everyone, my name is Jets Ignacio and today I'm going to discuss to you the examples and how to solve logic gates. Let's try to look the first example. Let's try to solve the output of input A, B, and A. Comment in the comment section what is your answer. Now let's try to solve. We have the input A and B and A. Now let's go first to the first input. Input A and B is connected to an OR gate, resulting it to an A or B result. As you can see there, A plus B is the answer. Plus symbolizes the OR gate. So when we read this, we have the A or B. On the other hand, we have the input A. Input A is connected to a NOT gate, resulting it to an A bar. So A connected to a NOT gate, resulting it to an A bar. The bar at the top of the letter symbolizes the NOT gate. And finally, we have the A or B and the A bar connected to the NOT gate, resulting it to an A or B A bar. Okay, let's try this another example. Comment to the comment section what is your answer here. We have the input A and B. Now let's try to solve it. Let's go first to the input A. Input A is connected to a NOT gate, resulting it to a A bar. On the other hand, we have the input B. Input B is connected to a NOT gate, resulting it to a B bar. Now, input A bar and B bar is connected to an AND gate, resulting it to an AB bar. Now, AB bar is connected to a NOT gate, resulting it to an AB double bar. As you can see, we have the AB or the NOT AB, and then we have the NOT AB. We have the double NOT here, and we just simply read it an AB double bar. Now, let's try the other way. How about the expression is given? Now, let's try to diagram this example. As you can see, the diagram shows the result, but let's go back to the expression. If we read this, we have the A, A or B bar and A. So let's try it solve one by one. As you can see, we have the three gates here. We have the OR gate, the NOT gate, and the AND gate. Now let's try to do the OR gate first. We have the input A and B. Input A and B goes to an OR gate, resulting it to an A plus B or A or B. Now let's negate A or B, resulting it to an A or B bar. On the other hand, we have the input A here, all the way from here, connected to an AND gate. Final result is A or B bar is connected to an AND gate together with A, resulting into an A or B bar A. That's all, guys, for the logic gates. Thank you for listening and have a great day. Please comment, subscribe to our YouTube channel. That's all. Thank you.